Hello everyone, welcome back. Today's day 4 of my 30-day FAANG grind, and I'm solving 6 to 10 LeetCode problems daily, breaking each down on video and sharing with all of you on YouTube. I'm Divya, by the way. I've interned at Massachusetts Institute of Technology, where my area of focus was on statistics and machine learning. Currently, I'm a top 0.3% globally on LeetCode, and like most of you, I am also preparing for FAANG interviews. So far, we have covered sliding window, two pointers, partition, and prefix and suffix patterns. Today, we are diving deep into string problems like substrings, character counts, anagrams, and all the classic tricks interviewers love to test. Before I begin, if you find this video helpful, please drop a like and share it with your friend who is also preparing. And please hit that subscribe button if it helps. Let us crack this interview side by side. Let us go. So, today we are dealing with problem number 3 for today, and it is 409, longest palindrome on LeetCode. I hope you know what palindrome is. So, we have been given a string S, which consists of lowercase and uppercase letters, and we have to return the length of the longest palindrome that we can build with those letters. Then it adds the conditions that letters are case sensitive. For example, capital A and small a is not considered a palindrome. Let us look at the constraints, and we see that the string length is bounded within 2000s and S is bounded within 42. Okay, let us go to the dashboard and we'll find an optimal solution for this problem. Okay, so before I begin, we have been given a string S, and this is the string, and we have to return the length of the longest palindrome that we can build. Cool. Let us think in a very different manner, first of all, and let me take you on a different very path. Okay, so assume that we have two different string types of two different character types, pink type and yellow type. You can assume it is A or you can assume it is B. Okay, but they are different. What do we notice? We notice that the frequency or the count of the yellow type is even 1, 2, 3, 4. And of pink type, it is odd 1, 2, 3. What happens when we have a string which is a mixture of multiple characters such that the frequency counts are either odd or even? How can we build palindrome from that? Or what is the maximum length of palindrome that we can generate in such a case? So we will try to explore that path, and that will become the whole crux and essence for today's problem solution. Okay, so we have two different types. We have even type and we have odd type. We must make sure that in palindrome every character is equivalent towards the end, right? If we move to different pointer, one from the beginning and another from the end, those two pointers must overlap, correct? Only then we can tell that this string is a palindrome. So in this case, how and where should we distribute the even part? Let us take a look. We distributed two even parts in the beginning and two at the end. This is equivalent to this. This is equivalent to this. Perfectly fine. How about this odd part? Since it is of type 3, since its length is of type 3 of 3, so what do? We break it down in an even manner, if we possible, and then we place those even parts wherever we want to. In this case, I have broken 3 into 2, which is even part, and I placed them over here. And as we can see, this part is equivalent to this part. Cool. Let us move to the next case. In this case, we see that we have three different characters, and all of them has a frequency count of even. Okay. How do we distribute them? The green part for me, I placed one towards the end and one towards the beginning. Okay. And this orange part, it goes over here and it goes over here, right? And this sky blue part, it goes over here and it goes over here. Okay. So we can see, hey, it matches that, it matches that, and it matches that. Perfectly fine. In this case, all were even characters and we were able to build a string. Notice one thing. When we had even characters, what is the length of this actual original string? It is 1, 2, 3, 4, 5, 6. When entire string counts frequencies were even, right? What is the length of the palindrome that we built from that? 1, 2, 3, 4, 5, 6. Did you notice something? one point that we can carry away from this example is if we have a string and if the frequency count of each and every character is even, then the length of the palindrome will be the sum of the frequency count for each and every even characters count. It is shown in this case, correct? Let us move to a different example and the last one. Here, what do we see? We see that we have three different odd characters and one character which has a frequency of even, correct? What do? We place it something like this, one in front and another in beginning. Now, how do we make a choice between these three odd characters? The thing is, when we have multiple odd characters of frequency count one, we can choose either of them and place them exactly in the middle so that it do not have anybody to compare to except itself. Okay, so this equals to that. Okay, and this purple one from the left is equivalent to the right one, purple on the right. Okay, so what do we notice in these three examples? When the character is even, the length will be the sum of all the characters frequencies. When the character is odd and even, in that case, we break this even and we split it in such a manner. And if we are just left with the odd characters of frequency count one, and if there are multiple of them, we can just choose one and only one of them and place them over here. But if we have even character and odd character such that the length of or the frequency of the odd character is greater than one, in that case, we will take we'll divide that by 2, okay, and we'll take that factor and we'll place it in the middle, something like this. Okay, when we take the factor or divide by 2, this frequency count is 3, we get the reminder as we get the reminder as 2 over here, right? This 2, and that is something that we place over here in the middle, right? And this even character, it is plated and placed either on the end. Notice one thing, in this problem, it do not asks us where to place. It just asks us to return the maximum length, okay? And our emphasis should be on computing the length and not on the placement. And by going through these three examples, I hope I have made it pretty clear how we can compute the length, not the placement, okay? Let us look at the code and we'll see how it goes. So in the first part, I have declared result length. It will be the length of the palindrome that we must return. And it is something that I have returned at the end. Then I declare the empty dictionary. Why? To count the frequency of every character. Why are we counting the frequency of every character? Because we want to make sure if it is even or odd, and then we want to deal with it accordingly. Okay. Then we scan entire string as, and then we fill the dictionary by computing the frequency of every character. And then what do? We have declared a flag variable called as odd, okay? And we have initially assigned it to false. It means, hey, we have not encountered odd frequency character as of yet, okay? And then I try to scan the dictionary. It should be order of linear time because I'm doing a complete scan. Similarly, this filling should be bounded with a linear time complexity as well. Now, as I'm scanning it using key and value pair of dictionary, what do I notice? In the first line, what do I notice? I note ask myself, hey, if the value is even character, then we are pretty much sure that we can split those even characters like we have done over here, and we can distribute it wherever we want, like this, like that, like this, like that, and like this, and like that, like that, like that, right? We can do that if the value is even. We can take the entire value, which will be the frequency, and that will become the actual length. We will append it in the length variable. We'll increment the result length by that value, okay? But what if the value is odd, okay? In that case, what we do? We say, hey, we have encountered an odd value character, so let us increase the frequency. Let us increase the palindrome length by value minus 1. And why did we do that? Why value minus 1? Or why we did not just put value over there? Let us come to over here, this example. We see that this is an odd character, right? How many values did we take? If I have an odd number, and if I want to take out even from this, how, like, what will be the even that I can take out of this? It will be odd minus 1. For example, if I have 7, so if I subtract 1, it will become 6. So odd minus 1 will always give me even, correct? So value minus 1 will always give me even character. And since we get the even character, we can distribute that even character either on the left, on the right, or on the middle in such a manner that they satisfy the condition for being a palindrome. That is our value minus 1 in the case of odd, okay? When we exhaust this loop and we come out of this loop, we ask ourselves, hey, is the value of odd true? If that is, then please increase the result length by 1. I'll tell you why we are doing that. And then we return the result length. Okay. Let us look at this thing. What was the need of this thing? Assume that our string is just this. Assume our string is just this A. Okay. And we start over here. We compute the dictionary, and the dictionary frequency will be A.1. Okay. Initially, odd is false. We scan the values. This will not pass. We'll come over here. It will return true. I mean, the odd will be assigned to true. Initially, result length is 0. Okay. We come over here. We ask a value -1. What is it? Value of A is 1. -1, it is 0. We are adding 0 to result length, which is initially 0, right? So result length will not increase. But when we come out of the loop over here, we ask, hey, is my odd true? It means, hey, did I encounter one of the characters as an odd over there? And if the answer is yes, we did encounter one of the characters as an odd. In that case, we just increase the value of result by 1. And this result length, it will go from 0 to 1. And it is something that we return over here, right? So yeah, that was all there was to this problem. The time complexity, as we can see, it is bounded within these two scans of order of n, and express complexity, it is bounded within constant of 42. Okay. So that was all there was to this problem. Let us go to the dashboard and we'll submit it. I have already submitted a solution for this problem. So I'll just copy and paste my code and I will click on run. And as you can see, it passes all the test case and the test cases have been submitted. I hope you enjoyed this video. If there is any doubt, please ask me in the comment. And I will see you in the next one.